An homogeneous series is a group of chemicals that share similar chemical properties and the same general formula. The trend in boiling and melting points is that as you increase the size of the molecule, you increase the melting and boiling point. And this is due to stronger intermolecular forces that need to be overcome. Molecules are made of hydrogen and carbon only if they're a hydrocarbon. A saturated hydrocarbon contains only single carbon-to-carbon bonds, whereas an unsaturated hydrocarbon will contain carbon-to-carbon double bonds or triple bonds. And the test to distinguish between unsaturated and saturated is that an unsaturated one will decolorize bromine solution immediately. This is due to the addition reaction that the bromine being added across the double bond. You need to remember the first 8 of the prefixes for carbon compounds. So 1 carbon is meth, 2 is eth, 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 is hept, and 8 is oct. You need to be able to describe alkanes from their structure, which is chain of carbons. They were all single bonds, and we'll have the general formula of Cn, where n is the number of carbons, H2n plus 2. They will all end with the letters A and E in. You need to be able to describe and identify alkenes from their structure. Again, the same idea. The chain of carbons. Somewhere there will be a carbon-to-carbon double bond, which you will have to give the name of. And they will have the general formula of CnH2n. And they will all end ene, E-N-E. You have to do the same with cycloalkanes. These will be in a ring, so they will start at prop, because you can't have single or double ones. And they again have the same general formula as alkenes, CnH2n. Their name will start with cyclo and end in ane. Naming a carbon chain, the alkanes and such. You first of all identify the longest carbon chain. This can have a bend in it, so be careful. Name the parent giving the lowest number for wherever there's, say, a double bond. You can name from either end, so it doesn't make any real difference. Identify and name any number of branches that's there. These change from being a methyl, meth to being methyls, or eth to being ethyls, as they become a branch. You group any like branches and add them with the prefix. If there's 2, di, 3, tri. And you arrange branches in alphabetical order, so eth will come before meth. You should be able to remember the general formulas. So alkanes, CnH2n plus 2, alkenes, CnH2n, and cycloalkanes, CnH2n. Remember the n's and the 2 n's are all subscript. Don't write them the same size as the letters. And join these things. Always start from the backs first. So look to see if there's a double bond. No double bond, then ane. Count the longest carbon. No, the longest carbon in this one is 5, so it's pentane. Look to see what the branch is. We have a single carbon branch, so that's going to be a methyl. And then you look to see what carbon number it's on. And it's on carbon number 2, so it's 2-methyl pentane. The same goes with the second one we've got there. That we've got longest branch, which is going to be 4, so it's but. We can see there's a double bond in the middle. That means it's going to be on carbon number 2, so it's going to be but 2-ene. There's a single carbon branch on one of the carbons. That's going to be methyl. And we can number that as carbon number 2. So it's going to be 2-methyl but 2-ene. So we've got homogeneous series part 2. Isomers. An isomer is a molecule that's got the same general formula, i.e. C4H10, but a different way of putting it together. So it's a different structure. As you can see there from the second panel, we've got butane, the top one, and 2-methyl propane. They're both C4H10, but they have different structures. Again, we've got different isomers there for propene and cyclopropane. You can move the position of the double bond. That will also give you isomers. So in the next panel, we have 2 there. We'll then start thinking about addition reactions. In an addition reaction, the double bond is broken and a molecule is added onto those broken bonds. So hydrogenation, that is where it's done with hydrogen. You can see there as an example. Hydration, that is where it's done with water, where hydrogen will add to one and OH, a hydroxyl unit, will add to the other. And if it's done with a halogen, as with the bromine test, then we've got the same idea there. We'll finish up with a bromo halogen. We now move on to everyday consumer products. An alcohol will always contain a hydroxyl functional group, OH, and it will always end with the letters OL, ol. The functional group could be anywhere on the alcohol. It could be on the first one, it could be on one in the middle. As with the double bond, you would just look to name the number during the actual name of the alcohol. The general formula for alcohols is CnH2n plus 1 OH or CnH2n plus 2 O. Either will do. As with all molecules, increasing the size will decrease its solubility, and increasing the size will increase the melting and boiling points of these things. Carboxylic acids have a carboxyl functional group, COOH. Their name will always end oic acid. The carboxyl functional group, as you can see, has a double bonded O with an OH from the third bond on the carbon. The most common that we come across is ethanoic acid, eth, 2 carbons, which is vinegar. The size of the carboxylic acid as it increases will affect its solubility, decrease its solubility, but again will also increase its melting and boiling points due to increased intermolecular bonding. The carboxyl group is always on the first carbon. As you can see with the last panels, the full structural formula for butan-2-ol, right, is wrong, as that is actually butan-1-ol. The OH should be on the second carbon for butan-2-ol. The shortened structural formula given there for hexane-3-ol indicates how things are done as you get further up the educational chain. Rather than drawing everything, you just put down the number of carbons that's fastened to the hydrogen as writing. The molecular formula for these is given, as you can see. The full structural formula there for heptanoic acid, again, 7 carbons, hepta, and finishes oic acid. The shortened structural formula again is given, as is for methanoic acid. And now we come to the last part of nature's chemistry, which is energy from fuels. First thing, just quick reminders. Exothermic, gets hot, releases energy, exit. Endothermic, gets cold, takes energy in, entrance. A fuel is a substance that will burn to release energy, reacting with the oxygen in the air. If it's done in plenty of oxygen, then we get carbon dioxide and water formed, assuming nothing else is present in the fuel. If it's done in a limited supply of oxygen, incomplete combustion, then we finish up with carbon monoxide, a poisonous gas, and soot, carbon forming. You need to be able to use balanced chemical equations to be able to find the amount of, say, water that's been made from a certain amount of propane. As you can see there with the balanced equation, I do apologise, the 4 moles of water seems to have slipped from the correct place. Remember how you'd lay that out. You'd have moles, for the things you're looking for. You then have the gram formula mass for those things that you're working out. You then have the actual mass. You then have the ratio of those things, so you could finish up finding the required quantity. Second part of maths involved in this unit is the EH equals CM delta T. You need to understand where error losses are with the practicals, as we've done when we've looked at it. We've got an example there as it's set up, and it gives you the various errors that could happen. One of the best ones is always the fact that governments do this. They use oxygen rather than air, so we finish up with completely different results. You need to be able to how to do that, so there's a few examples there on how to work it out for the energy required, on transposing the formula to work out the temperature change, and this is, remember, you will only be asked to work it out for per kilogram. You're not going to be asked to work it out per mole or anything like that.